Now we are in lesson 9.4. It's about vector equation of a line. In this lesson, we will talk too much about lines, kind of lines. You will see what we will learn in this lesson. The first part in this lesson, we're going to talk about parametric, vector, slope, intercept, and Cartesian equation of a line. You're going to see those four kinds of lines. It's the same method, but in the end, we can change the final answer to have it in the parametric or in the vector equation, slope, or Cartesian form. First of all, before we start all that, you need to know how do we define a line. Normally, to draw any line, guys, you need to have minimum 2 points. So you cannot draw a line if you don't have 2 points. Since we are in the vectors chapter, the line D can have a direction vector, but you can have many direction vectors. All those V, U, W, A, B, they are all direction vectors. But all what do we need? We need one of those direction vectors. And the easy one that we can find is by having 2 points on this line, and those 2 points we need to know their coordinates, and then we can find the coordinate of the vector AB, and we can name it the direction vector or the vector director. It can be AB or BA, it's the same. And to find the vector equation of a line, you take a point M. So let's say let's M be a point here on this line. What can I say, for example, guys, about the vector AB and AM? Those vectors are collinear. And you know from the preceding lesson, when I talk about collinear vectors, it means I can say that AM is equal alpha AB. It means I can AM and AB, they have a relation between each other. I can multiply the first vector by a constant to get the other vector. So I can say that AM is equal KAB. And what is AM? How do we find the coordinate of the vector AM? It's x of m minus x of a, y of m minus y of a is equal k times x of the vector AB and y of the vector AB. So what's going to be the vector equation of this line? So x of m and y of m, it's x and y because we said m is xy that belongs to the line D. And then if I take the xa to the other side, so it will be xa ya plus k x and y of the vector director. So to understand more what I'm saying, let's do an example, guys. So if I have the points a to minus 3 and b minus 1, 2. First of all, the first question, this is my line. How do you find the direction vector of this line? It can be AB, BA. It can be even eBay times 2, AB times 2. But I will take just one. I just need one. So I will take the vector AB. And let's review how to find the coordinates from the preceding chapter. Also, we know that. So it's x of v minus x of a, or v minus y of a. So, and then the coordinate of the vector AB will be minus 3, 5. Now, this is the direction vector of the vector AB. Now, how can I find the vector equation of this line? So, as I said, if M is a point here on the line, I know that AM and AB are collinear. What does it mean? AM is equal KAB. So, what are the coordinates of the vector AM? It's x of M, it's x minus 2, y plus 3, because y minus 3, is equal k times minus 3, 5. And now if I take the minus 2 and the 3 to the other side, this is the equation, this is the vector equation of the line AB. So x, y is equal to minus 3 plus k minus 3, 5. The same equation, this one, I can write it as a parametric Cartesian and slope intercept form. If I want to write it as a parametric equation, all what we need to do is just to write an equal x by itself and y by itself. So I can write x is equal 2 plus minus 3k, y is equal minus 3 plus 5k. This parametric equation, I can change it to Cartesian by taking the first equation, calculate k in terms of x. The second equation, calculate k in terms of y, and then we solve k is equal to k, and I have it. This is the Cartesian equation. I can keep it either like this, or even I can cross multiply, and you can find it in this form. And this Cartesian equation, you can change it to slope intercept form by solving for y. And you know that the slope intercept form is, or slope y intercept form is y equal mx plus b, and this is in the slope intercept form. If you notice here, guys, if you look at the denominator 3 and 5, what are those? You can see that those two can be the vector director of this line. Did I make any mistake? I'm just checking. 1 minute here, 3k is equal. No, that's it. That's right. And now let's move to the second part in this lesson, the normal and the direction vector. If I have the normal, how do you find the direction vector and vice versa? So we know when I say normal and direction vector, if this is the direction vector, this is going to be the normal. So those two are perpendicular. So if n is perpendicular to d, the normal perpendicular to the direction vector, it means the dot product is 0. So if n is x1, y1, d gonna be y1 minus x1. So let's give you an example. If I have the direction vector 2 minus 1, what's gonna be the normal? We just twist, it's minus 1 minus 2. So the x becomes y and the y becomes minus x. Okay, so this y becomes x here, and that is gonna be minus y. It's very important to mark, and the normal and the direction vector are not unique. I have many and many, because I just need one to be able to find the equation of a line. If you want to check if really they are perpendicular, do the formula x times x1. So it's minus 2 plus minus 1 times minus 2, it's 2. So the answer is 0. So I'm on the right track. Now, this part is very important. How are we going to study the position of two lines? I have two parts here. I just have, if I'm working in 2D and if I'm working in 3D, because in 3D, I have one extra position of a line. In 2D, guys, we know that when you're drawing a line, either the lines are parallel, either the line are they intersect, either the line can be coinciding or we say overlapping. How are we gonna see that? We have three methods. In the preceding classes, when you were in grade 10 and even in grade 9, how you were checking if the lines are parallel, you were checking the slopes. So I wrote this remark here, but here we will not use it. You're gonna just use the direction vector, but you can check your work by looking at that. If you know that if two lines have the same slope and they have different y-intercept, they are parallel. If they have same slope and equal y-intercept, so they are overlapping or we say coinciding, and they have different slope, they intersect. If I want to do that using comparing the direction vector, we know if the lines are parallel, so they have collinear direction vector. So collinear vector director, it means the lines are parallel or overlapping. So either they are parallel or overlapping. How am I gonna check if it's parallel or overlapping? Just you need to take one point on one of the lines and check if it belongs to the other line. If the vectors director are parallel and they have a common point, it means directly they are coinciding. And if the vector director are not collinear, though, it means they intersect. And I have another method also. I can solve the system of those two lines. If this system gives me one solution, it means they intersect. If it gives me, for example, 0 equal to 0, if it gives me 2 equal to 2, so it's true. So it means the lines are overlapping. And if it gives me a wrong answer, it means the lines are parallel. So I can compare the lines using the slope like we're doing in grade 9. Now, we can do it using the direction vector, or even I can solve a system. Okay? We'll do an example for that. Let's say I have those two lines. I'll put this one here. So let's say I have those two lines, and on purpose, I gave you two different shapes or forms of line. I have the first line, x minus 1 over 2 is equal y plus 1 over 3, and the second line, I have it this way. I need to study the position of those two lines. If I take the first line and 1, I can cross multiply to write it in the form of the slope intercept form y is equal to 3x over 2 minus 5 over 2. The second line is big, guys, you need to be very careful. So here you need first to develop. The I represent the x of the line. So minus 5 plus 2 lambda is x. So x is equal to minus 5 plus 2 lambda. And 6 minus 3 lambda is y. And then I solved for lambda for in the two equations. And I got here the Cartesian equation of the line. And then again, I cross multiply to get the slope intercept form of this line. And now I have the second slope intercept form of the second line. Those are the two lines. So this is the first line, this is the second line. If I look at the slopes, I can see that they are not the same. So I can see that they are not parallel. But also you can solve it. And when you solve the system, I can solve it by comparison, by substitution, by elimination, as you like. So when I solve it, I will have exactly a solution. So when I solve this equation, y equal to y, I can multiply it all by 2. I will have 3x minus 5 equal to minus 3x minus 3. Then I will solve for x. I got x equal 1 over 3. And then I replace in any of the equations either this or this to find y. And I got an intersection point. So it means that those two lines, they intersect. They are not parallel and they are not coinciding. And I could predict the answer by comparing the slopes here. Now, if I'm working in 3D, I have one extra case in this 3D, and this is very important. Now, also, either the lines are parallel or overlapping. So, how I know if they are parallel? If the director vector are collinear, it means they are parallel. But I need to check because if they are parallel, they could be also overlapping. Plus, if I could find a common point, for example, in this case, you take any point on the first line and check if it's on the other line. If you take any point on the first line, it belongs to the other line. It means they are overlapping. And the second case, I need to see if they intersect or they are skew. We say skew. It means I could have two different planes. One line is here, the other is here. But guys, there are two lines in different planes. They cannot meet as one is line is here and the other line is far from it and it's on the other plane. You cannot see it like this on the board. We will see it in the class. I will show it to you with the pencils, guys. Now, to be able to check if those lines are intersecting or skew, I need to solve the system. If the system gives me a solution, it means the lines they intersect. If the system doesn't give me a solution, it means they don't intersect, they are skew. How? Let's see. I have those two lines. The first line is it's x minus 1 over 3 equal y plus 2 over 2 is equal z over 1, and this is the second line. So first, let's compare the vector directors. So the vector directors are the denominator 3, 2, 1. This is one of the vector directors. Be careful, guys. It could be, you can say it's 6, 4, and 2. And this is the second vector director, minus 2, 3, 4. Let's see, are those vectors collinear? How are you going to check that? 3 times what gives me minus 2? Or I can do 3 over minus 2. Is it equal to 2 over 3? No. So it means they are not collinear. So I'm sure that the line are not parallel. So they are either intersecting or skew. So what I need to do, I need to solve the system. But here in this case, I need to have a system of three equations, x, y, and z. I'm going to have two variables. Let's see how we're going to solve. So this is the first equation, and it's those three are equal to a constant t. And this is the other equation, it's equal to k. And I need to find x in terms of t, y in terms of t, and z in terms of t. So if I take x minus 1 over 3 is equal to t, you cross multiply, you will have x minus 1 is equal to 3t. It means x is equal to 3t plus 1. To get the second equation, I take this with this one. Let me change the color, it's easier. So then you cross multiply, you will have y plus 2 is equal to 2t, so y is equal to t minus 2. And those together, I will have the third one. Exactly the same I do for the second one. So x plus 3 over minus 2 is equal to k. So x plus 3 is equal to minus 2k, and then I have the three equations. Now, you pick the two easiest equations that you feel it's easy to work with. What I will work with is the axis and the y and the z, sorry. From those two equations, I will try to find t and k. And when I will have the value of t and k, I will replace it in y, and I'll see if it verifies. If it verifies, it means the lines intersect. If they don't verify, it means it's skew. So I will take those equations x and z, and then I will try to solve x equal x, z equal to z, and they will have a new two equations in terms of t and k. Let's see that. If I solve, I'll just put this one here. If I solve x equal to x, it will give me 3t plus 1 equal minus 2k minus 3. So this is the first equation. And if I solve z equal to z, it gives me t equal 4k plus 2. And now this is a new system. I will do it by substitution. I will replace t by 4k plus 2. So I'll have 3 times 4k plus 2 plus 2k is equal to minus 4. And then I will solve for k. I got k minus 5 over 7. Excellent. I got k. Let's replace it in 1 here to find t. So t will be equal 4 times minus 5 over 7 plus 2. I got t. Excellent. I got t and k. Okay, I want to see if those value of t and k verify the third equation that I didn't touch it till now, this one. So I will put y equal to y and I will replace t here and k here and they should give me the same answer. So let's see what's gonna happen. Let's replace in y. If this is the first equation in the first line and this is the second one. If I would replace, look at it guys, 2t minus 2 is here, okay? And this is 3k, so I'll put t here, I'll replace it by its value and k by its value. So t is minus 6 over 7 and k is minus 5 over 7. I replace it and I reach to a wrong answer. If those were equal, it means the line they intersect. So if those are not equal and opposite, so no intersection, so what does it mean? The lines are skewed. So sometimes I will ask you, show that those lines are skewed. The skew case is just for the 3D when I have X, Y, and Z. Okay, guys, that's it. This is all the lesson. It's a little bit long, just the calculation, but it's easy as an objective. See you next time in the second